So, so I'm James Deaton. I'm the Vice President of Network Services. I'm saying that because, we heard this wonderful stat of all the first-timers in the room. For those of you that haven't met me before, I call upon people to get kind of some calisthenics in. So raise your hand if you're one of the first-timers. Really? That's a good set of folks. I guess some of the folks are first-timers for Community Exchange, but not necessarily for an event like the Technology Exchange. So welcome. And so I have a few background slides for those of you to kind of set the stage. So Internet2 Network Services recently wrapped, in the past couple of years, the next generation infrastructure. And this is the most concise slide that represents the set of services that Network Services provides. So we've got a set of layer 1, 2, 3 services, and it culminates in the ability to provide a peering exchange across commercial providers across the US, rapid private interconnect that allows us to provide discrete individual circuits anywhere we have a node in the network to be able to serve specific business needs of anybody in the network. It provides global DDoS protection through providers that we partner with. And one of the more exciting ones, the Cloud Connect, the fact that we connect to each of the hyperscalers, and over time we've developed automation for every aspect of that. So for those of you that are familiar with Megaport or Packet Fabric, it's like that except better. You beat me to the better part. And then ultimately at the core, what we're all about is supporting R&E on the infrastructure and making certain that our great institutions can push data without limits across to one another. So I always like to give updated stats and slides, and some of these stats have been modified just within the past 24 hours. And for those of you that really know me, they probably got modified in the last 30 minutes before I got begged for the slides to be put in. So this is our layer 1 network. The only things I really want to call apart is, excuse me, the fact that we're starting to do more and more managed spectrum across the infrastructure, which I think is fantastic. Later you'll see that within some of our relationships with the Advanced North Atlantic Consortium, that we've been able to do that across the Atlantic as well. I want to get into the layer 2 and 3 services. We now have 655 Cloud Connect connections. What that means are connections that are layered, either layer 2 or 3, going to one of the 4 major hyperscalers in various places across the US. I obviously give you a very difficult map to see for those of you in the back of the room and the front of the room, but you can see the little blue dots showing where those Cloud Connect sites are. Here's again, raise a hand if you've turned up a Cloud Connect connection on the network or been involved. All right, there's some good hands. Mary Ann, I have to call people that. Thank you. So this is my inability. I guess something in the conversion has taken an animation. I tell myself never to use an animation, but apparently it's not working the way it should through this system. So it's a good thing, too, because this actual slide is actually going to be gone into in incredible depth tomorrow afternoon at 4 o'clock by some of my colleagues, Scott Taylor and Chris Wilkinson. So basically what you would see here is an incredible set of capabilities associated with the Insight console. And what I encourage everybody in this room to do, if you haven't, bookmark console.internet2.edu. Further, if you're in a leadership position with your organization, I challenge you to reach out and make sure that you have a sign-in to log into console.internet2.edu and have yourself positioned as an auditor for your organization so that you can see all the great, wonderful things that are possibly already happening on your campus or that could be happening on your campus based on the visibility that the console gives you. Within the console, we're providing a looking glass that's available with an incredibly robust API that you're going to see leveraged with generative AI here in a little bit. We also provide the ability to programmatically and visually deploy new layer 2 and 3 infrastructure across this entire network. And most recently, we've been given the ability to see really the status of the routes in our R&E tables and our peering exchange tables, which is exciting because it ties right back to some of our routing to integrity initiatives. So I do have one that the pop-up didn't cover. So you can see a little bit of detail here. Reflecting the amount of user interface, the usability studies that we've given a great deal of attention to to make this interface incredibly robust, but also very, very understandable. And so we have a process here. I've got a bunch of cards here for our gentlemen on our team, and we got people here in the audience that has cards. We're doing a series of discoveries about the next set of features will be loaded in here. You'll hear a lot more about this on the meeting tomorrow at 4, or the session tomorrow at 4. The exciting thing is it's all fully automated. Engineers typically do not touch the individual devices. They go through the NSO, and it's just fantastic to see the amount of automation and the adoption that's happening within the community of some of these techniques. So here's just a view kind of highlighting the types of things that are happening in the network. The peer exchange, we've got over 10 terabits worth of connectivity to commercial companies throughout the U.S. We have the Cloud Connect, like I mentioned. We've got the 655 connections that are leveraging that, and ultimately the RPI. And so to give you an example of how this can occur, raise your hand if you're an R&E network, like a REN, like a state network or a regional network. All right, thank you. So if you look around and saw those hands, they're in a position where they're serving, many of them are serving K-12s, libraries, museums, and some of those are the ones that are leveraging Cloud Connect more than some of the higher ed institutions in the room. So it's really exciting. This kind of captures that opportunity where I know of a community college in Kansas that's leveraging this infrastructure to be able to turn up Cloud Connect. They're able to use I2CC to get through to the hyperscalers, and they're also seamlessly able to leverage I2PX to get to the commercial entities. So the thing that's been accomplished over this time, please raise your hand if you're in the room and you can spell A because you're part of the table. Yeah, come on, raise them proud. There we go. So these are all folks that are involved in an amazing global collaboration that's established over 3.3 terabits of capacity. It's a mix of a lot of engineering effort, a lot of interactions to deal with this complexity, to help make sure that bandwidth is used productively for the furtherment of science across multiple countries. I'm excited because Internet2, we've helped manage several of the global exchanges on the East Coast, but further, it puts us in a position in North America to partner with some great folks to build this consortium, this collaboration called the North American Research and Exchange. Raise your hand if you're actively part of the NAREX. Thank you, Julio. So great number of folks involved in making this possible. The nice thing is it means all these connections, like within ANA, and other partnerships on the West Coast and South are able to provision programmatically capacity across the nation because we're working together, taking opportunities that NSF and others have helped provide to be able to make these international connections possible for everybody. Further, it allows us to help do really amazing experiments that may be just completely based in North America when it comes to turning up interesting experiments at supercomputing or at OFC. So that's my background for all the first-timers, all right? So I hope that many of you that aren't first-timers, you've probably heard most of that many times before. And some of you in the room, especially the RENs, have heard of this concept of the Trusted Infrastructure Platform, or as some of our community members in recent meetings have been referring to it as the Trusted Infrastructure Program. The idea is we, as a community, finding more challenges in showing the value of what the R&D network provides that's unique to what can be achieved with commercial networks. And so internally, we've worked a great deal trying to identify a set of objectives that we could put a great deal of effort, but could also be adopted by pretty much any REN, any in-REN, in the US or around the globe. And so this is a start. We've started engaging with members of the community. I was able to rally 30 different REN members into the Dallas area, into a small town called Southlake, and they were able to give a day and a half of their time, and we were able to spend a great deal of discussion on what this meant, where we could find alignment, what things resonated, and what things might pivot. And so I wanted to give the rest of this time to go over those items. So here's the network I showed earlier. It's a little slightly different view. But the one I quickly pivot to is this one here. which is the Quilt network, Quilt map overlaid with the Internet2 network. And I thank the Quilt for putting this map together all the time, because the connectivity to the institutions in the US are only made possible through the work with the RENs. And so as you can see here, there's a very complex map with various levels of complexity in individual states, individual regions, but they all work together to serve the universities and the K-12s and libraries and museums across the US. And so these are the folks that I mentioned we brought together. We've been rallying on the concepts of this trusted infrastructure platform. So what is it? I'll go into it instead of reading this entire slide, but let's start with the first one, the support of national and global research. When I asked this one, it's like everything we do is supporting national and global research. Well, internally, and at several of the RENs, we all agreed that there were things that we weren't doing to specifically support science, other than giving pipes, right? So NAREX, I think, is one good example of us officially putting programmability and cross-domain ability to engineer new circuits, supporting science needs, and be able to work with the folks that are pushing data-intensive activities across the network. But further, there's opportunities for RENs to contribute to initiatives and infrastructures that are on top of the network. So this right here is the National Research Platform. It's a visualization that they provide. Again, it's afternoon, you're still back from break. How many of you don't know about the National Research Platform? Come on, raise your hand. It's good if you don't know, because it gives me a reason to talk for a moment. Thanks, Karl. So the National Research Platform is an interesting concept that's originated in UCSD with a number of different partners, Nebraska and elsewhere, that have put together a concept of a Kubernetes cluster that's across the country. In fact, it's across the globe. There's nodes. This is just focused on the US, but there's nodes in several European countries, and I think there's, I can't remember some of the locations. I have to zoom out sometime again to see where they are. But you can see that there's 82 sites around the globe, 412 nodes. It's an international Kubernetes cluster that's available for research and education. It's also, and we are in research and education ourselves, so we are in a position to leverage these resources for ourselves to help demonstrate value and help bring value to the members that we serve. And it's a way that RENs can help institutions contribute to a national resource or an international resource. So for instance, there are CC Star grants that, the Campus Cyber Infrastructure grants, that have provided compute and persona testing nodes, often to campuses that may not have the staffing to be able to support that. And so this is a way that RENs and Internet2 can work to establish a greater foundation where people can contribute hardware to this infrastructure, not contribute unnecessary or unavailable staff resources that are local, but faculty get the benefit, staff get the benefit. The interesting thing here is every network engineer at a REN or at a campus can get access to this institution and be able to do persona tests on any one of these 412 nodes. It's an exciting opportunity for not just research, but for also troubleshooting the tasks that the network research, the researchers are using. So I'm excited about this. You can see some of the numbers, but we have found that we can contribute to it ourselves. The green boxes, most every one of the green symbols up there are contributing to the OSDF, the Open Science Data Federation, but they're also providing compute. We're also adding all of our performance assurance service nodes, which are basically perf-sonar nodes that are very beefy. They were meant to run multiple machines. We're adding that to this system. So not only are we going to continue to be able to gain better intelligence about our network, but we're getting the opportunity to build new Jupyter notebooks, to do AI classes, to be able to do Python training. And so it's very exciting to see some of these things right here. It's like at this moment when I took it, there was only 84 Jupyter pods running at that moment, but those 84 Jupyter pods are probably serving, a couple dozen classrooms each. So I mentioned the OSDF. These are areas where supporting global research and science is something that the RENs have a play, because it's adding infrastructure and counting on NSF-funded projects that can help maintain that on our behalf. Another way that I think we see supporting science and research is actively partnering with organizations like CADA. I'm very excited because we have people on our team that are co-authored and help develop new methods to help understand situations that are contrary to what we would think best practices in a research network, like local prefing a local peer for commercial use, and it has an unintended side effect of routing away from the R&D network. And so we've been able to develop a way, working with CADA, that we've put a paper in, and I'm trying to encourage other RENs to do that too, to be able to take advantage of the resources, the capabilities, the infrastructure they've got to help enrich opportunities for research down the street. So that kind of leads into this one of the more important objectives I see, which is having two aspects: the technology understanding and the community of engineers that are devoted to the value of R&D networking. So it's a convoluted way to say this: driving community evolution of peering and routing optimization. I've been sticking to my guns on that one, and I'm waiting for a better alternative for that. But it's really about keeping the level of intelligence about what are unique to the engineers that help start most of these RINs. They've retired, they've been pulled industry. So there's opportunities to bring in training and awareness of making certain that the right routes are being used. And so this is just, I like to share this one because I think it's slightly dated, but it's a picture of all of our commercial peers that go into I2PX. You can see that there's about just short of 11 terabits of connectivity between the direct P&I connections as well as the public exchanges. I circled on here one single 10 gigabit link to Cox Communications. And for those of you who don't know, Cox Communications is a pretty prominent broadband cable provider. And over time, because of the scaling of the networks and the ways that the R&E networks are distinctly peering with them separately, none of us have been reaching the levels that allowed them to want to stay peered. And so over time, they've de-peered with everybody. I don't think I've found a RIN that really has a good, solid peer in the US. We have 1 10 gigabit connection still in Dallas. But if we did things together, and if we all understood how to leverage our collective eyeballs that we have in our networks, we could change the picture here and be able to see more settlement-free peering to help, benefit all of the R&D community. The third one here is something that for those of you who know me, 2 careers ago I was pushing on this one, and I think many of you in this room are involved in wanting to improve the network transparency, because that's our superpower. It's the thing that anybody in our network realizes that if they're part of an R&D network, there's going to be somebody that cares about the delivery of packets that's impacting our goals of our organizations along that entire path. And so we need to bring transparency to that. And so I'm very proud that we're one of the founding organizations within Metronova. Many of you, here's a chance to raise your hand, raise both hands if you're a Metronova consortium member. All right, see, look around you. These are other people that are very devoted to getting to this idea of having practices in place so that we can have better network observability and analysis. And so I'm very excited about the work that's been happening in that group. And I think it's one of the core pieces going to get us in a position that helps lift all the RINs. I put a quick slide in here thanks to Karl. Karl's a contributor to this effort. We've got many of you in this room that's contributor to SciTags, but it's also related to 2 aspects. It provides more transparency about the network, but also kind of celebrates the science traffic that comes across our network. And it's key to helping enrich our understanding of the value of the network by letting individual science projects flag themselves for what they're accomplishing. So, and then if you've come to any Internet2 activity over the past couple of years, we've been trying to highlight the situation of routing integrity in the R&D networking space. Many of the institutions across this community are legacy holders of IP address space, at least within the ARIN world. I mean, I know looking around, I see a lot of international folks. There's different policies and agreements that have to be put in place depending on where you are in the globe. But in ARIN space, there's a lot of legacy holders that have different reasons for not signing agreements, putting the right documentation in place to be able to improve routing integrity. So we see an initiative that's very important to help flag the unique value we bring into improving those aspects. And so we've got a number of initiatives that have been underway, and we've made incredible progress. And if any of you have met Steve Wallace, who's who's globally advocating for some of these things. He's got some great reports. The thing that I'm excited about is that we've recently rolled into the Insight console a way to visualize. So anybody that we peer with within the network on the R&E side or the PX side, you can see what routes are being accepted or filtered and why, see the status of where they are into multiple data sets. There's a really great pipeline that's collecting and enriching this data, and it's helping lift all of us. So I just want to, in fact, this is, when did this feature roll out? Within the last month. So again, go to console.internet2.edu. It's something that you should click on and explore. I'm really excited because it takes what was a very boring spreadsheet and makes it a really fun thing to navigate. And of course, you can have friendly competitions with your institution down the street. And lastly, I think most importantly, is leveraging the amount of automation and software and AI-enabled services that we're able to put in our network. There's so much advancement in this space, and so everything we've been doing since even within NGI, what started NGI was adding automation to the network and focusing on software. And so we've got this great foundation, and we're seeing greater adoption across the community. We see other folks spending a good amount of time either leveraging SO, workflow orchestrator, things that we're starting to look at to be able to get all on the same page in capabilities and help lift each other. I was very excited that we've got more folks as members of Internet2 associated in this space, and so I think it's a great opportunity and probably one of the most important initiatives that we've got. So I share this one because I was really excited. It gave me an opportunity to take a well-documented set of meetings over a multi-year period. We got Shannon Burns, who you saw at the podium earlier. She's one of the organizers of this. But this is just me with one Claude prompt saying, hey, here's the notes for the past 2.5 years, I think, for everything that the network automation SIG has been doing. Please help me understand it in just one slide. And I'm sure it's got some errors, but it was very insightful. It showed, you can see a progression of the types of conversations that was happening in 2023 versus 24 and 25. But the point I see in this initiative, it's not just about the technology, it's about the community that you're building. So you see that there's over 50 institutions over this time that have been participating on average for over this entire time, at least 20 people per session. And I used to enjoy getting to lurk on here and learn that they always lift at whatever level. If somebody's just learning how to use a Python script to do a config drawdown versus the folks that are leveraging and building the latest NSO models, they take care of each other. And so it's kind of advertisement to get involved, have somebody get into this community, because it's just, they ask for more meetings. So they meet like twice a month because people just couldn't get enough. Anyway. So with that, because of all the automation, I couldn't help but share this slide here. This is actually a report that our wonderful Network Architecture and Operations and Planning Program Advisory Group, our NAOP PAG, just endorsed. And it's a report showing the culmination of all this automation, the Cloud Connect services that have been in place, and more importantly, the fact that it's been well adopted by so many of the organizations with Internet2, 655 Cloud Connect connections. This is our attempt to show the value of that, basically by comparing what it costs in our network versus what it costs across the lowest cost public commercial provider for this. So I don't want to take too much from that. We've got Scott Taylor somewhere in the room that's going to be talking more about this tomorrow afternoon at 4, so you have to go to the session tomorrow at 4. I was going to say, so hopefully you all have a QR code reader that lets you see everything it shows you. So it's a challenge. If you don't want to see it, we'll get it to you in paper form, Karl. And so this last one, and it's probably best given the amount of time, this was just me and the team trying to show things that are underway right now that we saw that align in those initiatives from our perspective. I was very thankful for all the principals. That's who we call the RIN leadership that we brought together. I'm going to make them raise their hand. I haven't done that distinctly. So many of you have raised your hand in some form. Raise your hand if you were in South Lake last month. Okay, thank you. That was a good group of folks. I hope that it was really an amazing time in my mind because it was so many faces have changed over the years. It was the first time in like 9 years we'd had a dedicated meeting like that. But in the conversations, we found where works that were happening at different RENs across the U.S. fell into these initiatives. And we had a lot of great feedback on what we should do next. And so what some of that was led to is establishing some working groups to dig into the meat of some of the highest priorities that either aligned with the initiatives of the Trusted Infrastructure Platform or were aligned with the most immediate needs across a broad cross-section of those RENs. And so really what we see within the Trusted Infrastructure Program, it's really a call to action where we want to rally and find these common set of initiatives that we can adopt and lift practices where no matter who you are in the nation or in another country, you can point to this set of initiatives as something that we're adopting so that we can start messages about the unique value proposition of RD networks. So coming out of those conversations in South Lake, we came up with a number of working groups that we needed to launch or we needed to align with existing efforts. And there's a gentleman named Jim Stewart who is a bit insightful. And this is my handoff so that I can let somebody else praise Jim in the right way instead of me. So with that, Karl, I'll let you take over.
So as James mentioned, one thing that came out of the network principals meeting, and actually kind of before that, what we're calling right now the REN AI working group. So after last TechX, there was a lot of AI talk, and Jim Stewart approached Jim and I and said, hey, I'm all in. Our community needs to understand AI, probably needs to adopt some AI, and so let's get a group of people together that want to work on this, want to actively work on this, and so that's what we started to do. We started doing. We actually have a pretty active group. So again, this is spearheaded by Jim at UEN, and it's a working group that's focused on execution and collaboration. And so we're really looking for folks that want to get involved and want to work on various AI efforts. In the first few meetings, we identified essentially what we're calling 3 focus areas, and we have leads for each of those areas. So one is in the AI chatbot world, it's called retrieval augmented generation, but this is how you can have a conversation with a chatbot that looks at your documentation or your wiki. So if you normally interact with ChatGPT or Claude and you're asking it questions, you can't always ask it questions about your institution. Like maybe it might know something about your institution based on your website, but it probably doesn't know anything about it definitely doesn't know anything about internal documentation or your wiki or ServiceNow or Salesforce. So this is a way to attach chatbots to your documentation and get more informed information out of it and have a conversation with your internal documentation. So John Peterson from WISNet, I think was voluntold to lead this effort with the latest meeting. But he's interested in a lot of this work and doing that. The second area is, and I'll show off a little bit of this later, is a chatbot for network troubleshooting, and I'm leading this group. And here again, you can ask a chatbot, about networks and about network configuration and give you really good answers, but I can't ask it any information about my network. I can't, go to Claude and say, what routes do you see on my network? But now there's a lot of new advancements in AI and how some of the LLMs work that we can, it's actually called tool calling. So we can build tools. In our case, these are just Python functions. And I can tell the LLM about those tools available to it, so I can have tools to talk to my network. And then it can make decisions on that and give a response back to my application. My application will run that tool on its behalf, return the data to the LLM, and it can make an inference on that data. So now I can ask questions about, maybe I can ask questions about my network, and allow the chatbot to run I run those tools on behalf of the LLM and get some answers back. And the idea here is now we can connect operational data with an LLM and have it try to do some work on your behalf. The initial focus here when we sort of think about this idea is, I want a tool for my network engineers. I want a place for them to start. When they're troubleshooting an issue, they can go to this chatbot, type a question in human language, and maybe the chatbot starts making decisions about what it's going to go check, the routers it's going to look at, collect all that data, return it back to the engineer, and at least now they have a starting point for troubleshooting an issue, and you'll see the commands run. They'll be able to go verify it. But you can start to think about how you can expand this. Now you can have an automated workflow where a ticket comes into ServiceNow, kicks off a process, does all that information as well, does all that gathering, has the LLM makes an inference and makes a summarization of what's going on and puts it in a ticket, or even all the way up to having your members have access to something like this to ask it a question. James mentioned the looking glass on the inside console. It's a really useful tool because you can run commands on our network, but it's very much built, it just runs real commands on a network. So you have to know how to run a command on a Cisco router. You have to know how to run a command on a Arista router. And if you don't know the syntax, you might struggle with coming up with that. But if we have something like a chatbot in front of that, taking care of that work for you, you can ask the chatbot the question, very simple question, and hopefully it turns it into the right commands to run on a network. And lastly, we're also looking at machine learning. We have all of our networks have lots of telemetry. We have lots of data on our networks. We have lots of NetFlow data. So Troy Jessup at UAN is leading this effort, and he's been already doing a lot of work with machine learning on NetFlow data for security analytics. But there's also a lot of opportunities here. A lot of us partner with the IU Global NOC, and they have access to lots of our data. So, can we start doing, some kind of machine learning against all of our data sets? What can we learn for, end to end across our network? So again, we have a lot of organizations involved in this effort, but we're always looking for more people that want to get involved, especially people that want to contribute some resources to doing some of this work. We don't just need software developers. We need software developers to write some of the software, but we need network engineers for the chatbot. We need use cases, but we also need people to validate that it's working as intended. Run through some scenarios for us. Ask it. We can develop virtual networks. We can break them and have an engineer try to troubleshoot that network. And is the chatbot doing the right thing? Is it giving you the right answers? And if it's not, let's figure out what we can do on the back end to improve that response. We need system administrators, folks that want to work on standing some of this infrastructure up. Or James mentioned the NRP. They have lots of GPUs, and we can run a lot of these open source large language models on the GPUs. And in fact, NRP runs a bunch that are accessible through an LLM proxy. So you just need an API key, and they already have access to LLMs on NRP. But we've found out right now a lot of the open source models, and we're trying to figure out why they don't work well for tool calling, and we don't know why. So we just need some folks that want to spend some time spinning up these services and help us troubleshoot. We don't even need technical people. Again, talking about especially the RAG chatbots. One conversation we had was, if we had a chatbot that was looking at all the members' websites, could we start building marketing documentation? Can you ask it questions, or can you just have it kind of how James showed for the automation SIG? Can we generate one pages for all of the members? And so we need folks that kind of understand how to present that information, and can you query a chatbot and get the information you want out of it. So really kind of any resources folks want to put behind this, would be great. Anything else? Nope. All right. So now I was going to do a live demo, but we're going to do semi-live demo. So again, we've been working on a chatbot for network troubleshooting, and the real ultimate goal here is to, again, have something that can interact with your network, and your application runs commands, and we're having some success with that. But in a conversation I had with James Deaton a while back, he challenged me and said, do you think we could actually use this against the Looking Glass API in the inside console? I was like, oh, maybe, I don't know. I've never tried having a chatbot just automatically figure out how to use an API. But so we went and, actually it took, less than a day to get these tools running. We already had this framework going. But I only wrote 2 tools. And again, tools are just functions that get passed on to the LLM. In this case, we use Claude Sonnet running in AWS. One tool is this looking glass spec, and all it does is it goes out, because the inside console is all written in fast API, you have an automatic API spec as part of that. So this tool queries that API specs, and that's a well-defined JSON document. So it understands, well, the spec says how to run commands against the looking glass. And then one other function, and that's basically how to query any of those endpoints. So call the endpoint and pass in parameters. And that's it. That's all this chatbot knows about running using the looking glass. And so then we came up with a set of questions we asked it. And again, I kind of pre-populated these, mostly because sometimes these queries actually take about 30 to 40 seconds, as there's a kind of a looping process where the AI knows about these tools, and it can call a tool, and if it doesn't get enough information, it can do that in a loop, and it can call the tools multiple times. So it might have to iterate over this. And so if it doesn't get it right the first time, it can ask a couple different questions, and that just takes some time. So again, the first question we ask, what devices are available? And as you can see, it goes and, if we have time, I can show off what happens in the back end, but it goes and it queries, it pulls down the API spec, and then, queries the right endpoint, which is just a devices endpoint, and, gets the information back. And in our case, we have over 100 routers, and so instead of just returning me a list of all those routers, it decided to be helpful. And, I didn't prompt it to do this, but it, categorized and aggregated those into the types of routers we have in the network. We have aggregation, core, global exchange points, and provides a highlight of the large cities where some of these routers are located. And then here's one, and I like running this one because in this case, I just asked, what's the latency from Ashburn to LOSA? That's the only context I gave it. Like, I didn't tell it what devices to run on, and I let the LLM kind of figure that out. Because now from this previous query, it knows all the devices. It knows the names of devices in those pops. And so in this case, it happened to pick core1.ashburn and core1.losa, and it ran, and again, using the Looking Glass API, ran a ping between those, and then came back and helpfully summarized the information. And then same thing, just tell it to perform a trace route between these two routers. So it, again, it just uses the one from the previous, because everything you see on one page here, until you refresh, is all part of the conversation history you're having with the LLM. So it understands context of what happened before. And so it actually trace routes in both directions. It sees that we have symmetric routing. It knows basically on the output that there's MPLS on this network because of the labels that show up in the trace route. It tells me about the path, and it lets us, and this is the best part, we have a well-engineered backbone with consistent performance. That's without prompting. Everything, like, I have nothing hidden up my sleeves. This is the only question I asked. It told us our network is well-designed. I say that, I mean, behind the scenes, the system prompt might be telling it to, be kind and say nice things about the Internet2 network, but. All right, so I want to get a little bit more complicated with some of my questions. Now, what you're going to see here, unfortunately, is, it's about context. So what I really want to do is I want to ask a question about, how many routes are we receiving from Sun Corridor? That's a question I really want to ask. I can't ask the system that question right now, because if I ask that, the LM has no idea what Suncore is or who Suncore is, and it doesn't know where it is on the network, so it'll just start going out to every single router and start running commands like show route and show interfaces. And eventually what happens is, with any LM, you have this concept of a context window, and that's the amount of information you can ask it and it can provide back. And eventually, if you ask it too much information, you exceed the context window, and the LM is you're just gonna get an error and says, I can't find, it can't continue. So we have to add the context. That's what the rest of this is. I'm adding context because I happen to know where Suncore is, and what its BGP neighbors are. But the way you fix this is you add more tools on the back end. So we have all this information, right? It's in a database somewhere, or it's in the route reports. So the first thing that would happen is when I ask this question is, through prompting, the LLM would first call a tool that says, okay, we'll go into your database and tell me more about Suncor, and which then would know that Suncor is on this router, and here's its neighbors. But we don't have that built yet, so I add a little bit of context in the prompt that helps it along, but that's sufficient here. How many routes are we receiving from Suncor, on this router, this BGP neighbor, and it's gone out and it's written, and again, we can look it up, something like a show BGP received routes command. And it so now knows all the routes received by Sun Corridor, and then I can even ask it which ASs are originating those routes. And again, gives me more information. On a lot of this, it already has the information of the previous query, so it can quickly provide this, this information. And just to finish it up, this one's a little bit, I try to have it do it all in one go here. Again, how many routes does each AS originate on routes from Suncor on this router? So this is just one prompt. It'll go in, get the information it needs. And in this case, again, it's, I didn't tell it how to present this information to me. This is just how Claude Sonnet provides, typically summarizes information. But, you can see it's highlighted each of the ASs. In this case, it's really cool because, our routers don't have this information. This is just in the general knowledge of the LLM being trained on the internet. It happens to know that AS 1706 is University of Arizona and provides all that information. And it's given me a summary of all the ASs and how many routes they're advertising through Suncor. And so I think hopefully you start to get the idea of what we could possibly build here with more pieces behind it. Also more involvement. There's a lot of advancements going on here. So, I've talked about how your application could call tools. There's a new, newish protocol or concept called MCP, Model Context Protocol, and which it's a well-defined interface for for your application to talk to, and people could build little MCP servers for different parts of this. Like I can have one for talking to the network, and somebody can have one for talking to who is our IRR data, and another one talking to ServiceNow. And then we don't have, everybody doesn't have to build their own their own tools. We can have a community of these tools around here. We can share them and we can deploy them, and we can start to build something that using human language. Go in and ask these kind of questions and get answers that make sense out of the network. I have 6 minutes. Oh man. Well, let me do two things. Well, we can also attempt to ask it questions live if somebody has an interesting question they want to ask. But first, I want to. Well, I don't actually know. This is going to redirect. So this is not related to this. But this is if I don't know if you folks can see that. If you go. Because this will redirect. So, James talking about how Christopher Green working on the base of the discovery process for the next things we want to deliver for Inside Console. We have business cards around that we can hand out. Most of the folks on our team have them. But Christopher would love to hear from folks on, what do they want to see next in the Inside Console. And so one way is get that business card, or if you go to console.internet2.edu/comex25, you'll get redirected, and that's why I can't just put it up there, because you're going to get redirected to Zoom to schedule a meeting with Christopher, and he would love to talk to you and chat. And again, everything we've built in the Inside Console has come has come from the community, and new features that we're building has come from the community. So we want to hear about what features you want to see in the Inside Console. So with that, we'll go to questions, and if somebody wants to try to break the chatbot, we can attempt to query it live. Live demo? Well, give me a question. What do we want to ask? What's broken? That'll definitely just error out. What? Well, the problem is, I'll ask it, but the problem is it takes 50 seconds before it'll eventually. What's broken? Yeah, I have no idea what's actually going to. We can actually look to see what it's going to do in the back end. Oh, cool. Well, there we go. What's the longest path across the network? See, I can't. I got to figure out how to. Well, no, I can tell you what. I know exactly what's going to happen. It's going to time out because it's not going to. It's not. Again, we're missing context. But yeah, let's do it. But if I'm just trying to think of the right way to phrase that from a starting router. network. What's the wrong path across the network? Let's just use core1.losa. But again, the problem is this is going to spin a while. It's going to run like, it will, like, I suspect two things will happen. Usually the errors you're going to see is one, you hit the context window or you actually hit a recursion limit. Because again, I should have thrown up a state diagram here. Well, I could probably pull it up, but it's basically, you have an assistant or the AI or the LLM, and then you have a tool, and there's just a loop between those. And so like it gets the tool back and it'll be like, oh, I don't have enough information. Let me call another tool. And you'll eventually, if it never gets the information it thinks it needs, it'll just hit a recursion limit. Like, and right now it's pretty high. It's 25, and that really needs to be a lot lower because you don't want to spend that much time digging around.
Can we do it for something along the lines of network planning? Like, what's the optimal path between these two sites only using 400 gig links? We have to repeat the question.
Yeah, I mean, we could try that. I don't know. I don't know if I don't think I would try that right now, but it's something we could certainly look at.
Just curious.
Yeah. And again, would it work right now out of the box? No. But that's the kind of things that we want to build towards is can we ask those kind of questions and can we have an LLM help us, answer those questions if it gives enough information on the network or, or on any of our other information. Joanne?
I was just going to say, one of the exciting things that I like about this is the API has a spec, right? And the more documentation, the more awareness of what the tools can do, the more capability it has. And that doesn't take a programmer. It just takes somebody that understands the network to be willing to help provide context in a different sense. Not the context window, but the context of what the tool can do. And so it's exciting to think that you can bring more people to the table to learn about the process. And they don't have to be developers. They don't have to be network engineers. They just need to maybe just explain a process. And so I'm excited about this path. Thank you, Karl.
I have no idea why it decided to run any of those commands that it did, because I doubt. Oh no, I guess core one. Yeah, so it just ran a whole bunch of trace routes. Yeah, well I don't know. I wasn't going to show it off, but here you go. We could dig through this. This is actually what it decided to do, and. Yeah, there's a whole lot in here we could dig through, but yeah, basically it went inside it. Yeah, it was just running a whole bunch of trace routes. But yeah, so actually, interestingly, it worked. And yeah, it's LOSA to Boston with 9 hops.
Sounds about right.
Yeah.
So my question is, you've been saying like, well, I need a tool for that. I need a tool for that. So one of the things I've been playing around with Claude is writing tools with the engine. Have you looked at? I asked it to do a thing, it said it couldn't do a thing, and then you then turned around and said, hey, write me the tool that you need to actually answer that question? Is that something you've tried?
No, that's actually a good approach. I have not tried that. I can say a lot of this is just a looking glass tool. I do have a handful of tools for actual network troubleshooting, and AI did write most of those. Basically, I just said, write a tool for show interfaces.
Right.
But I haven't done what you're saying, which is actually a really interesting approach, and I will definitely go try that. When it can't answer something, I could, ask it, well, how could, what tools could we provide so you could actually provide that answer next time?
Yeah, exactly. Either what do I need to write or what can you write?
Yeah.
Cool. Thank you.
All right, I'm getting the closing or the get off the stage music. Oh, we got one more. Brenna.
Hi, my name is Brenna Mead. I'm with IU. I was sort of thinking about the keynote as you were talking and that discussion about she built this tool for the nurses and the nurses didn't use it and didn't want it. How are you as an organization working with your engineers and shifting the culture so that are they actually using this and what are you doing to push them towards using this culturally within Internet2? Because I think that'll be a question that many of us will have to answer.
I'll get back to you. Well, no, I mean, we haven't. This is not a functioning this is not a functioning tool yet. We haven't really done it. It's more, yet we're sort of in the build it and they will come stage, and hopefully they will. There has to be enough there to show utility of the tool for me to put it in front of them. So that hasn't happened. So yeah, this could turn out to not be useful, but. I still think even if it's not just for our engineers, it's something we could, I mean, right here, just this looking glass functionality. what if we package this up and, you know, all of this code is available and you could deploy this on your campus? Everybody could deploy something like this Looking Glass. Now, even better, do something like, you know, with Persona, like a registry service. So we now know all the Looking Glass servers out there. Now I can go into a chatbot and I can make a query about the entire, not just our network, the entire membership, you know, networks that are running these services. Can we ask interesting questions of multiple Looking Glasses to troubleshoot an issue? And again, we don't know because we haven't done it. It's one of those things we have to put it out there and does this work? And the cool thing about this, again, this is, you know, the writing the chatbot, this UI is really easy, and just pointing it at an API spec. That's all we did, and it does the rest. And like this is could be a good way for people to again interact with the Looking Glass, so you don't have to know bespoke commands. Cool. Yeah, we'll figure it out. Oh no, here we go. No.
No, I'll be good. One last question. I thought I heard you say that you actually use the LLM to build some of the tools themselves.
Yes.
Did you have any problems with the code working right off the bat, or did you need to go in and hand tool it at times?
I have problems with my code working off the bat, so it's really it's just the same. Yes and no. I mean, the thing is, especially with something like once you write one tool and it works, it's like LLMs are really good at hey, just do the same thing for some slightly different command. It's really good at that, so that works really well. Yeah, there's always problems one of the tools, or I was integrating it with AWS and in the Python library. It kept rewriting one of the class names, the wrong name, because I think that changed over time. And Claude just knows it from back before November 24, which is his cutoff date, and that so it kept rewriting it. But there's also tons of times where the first time it writes something for you, it probably doesn't run. Like you run it. But you know what happens? You run it and you get an error and you get like a Python stack trace, and you just paste that into the LLM and say, this is the error I got. And it's like, oh yeah, hey, I made this mistake.
It's a follow-up. Did it make your job easier?
Yes.
Okay, cool.
Yes.
That's all I need to know.
I am encouraging my team and anybody, like this is, it is not going to replace programmers. It is a tool. It augments what you do. It saves you time on certain tasks that I don't need to spend time on. Like another thing I had to spend a lot of time on, because I built a lot of this for a workshop I did yesterday. I have a whole bunch of bash scripts that did stuff to all the lab environments to break the network so people could use the chatbot to troubleshoot it. I didn't write those bash scripts. I mean, I can write a bash script, but I can also I just asked the LLM to write this for me. And it went and it did it and it did it well and it worked. And that saves me time because I'm not spending time writing that script. It is a time saver, and you have to understand what you're doing and what you're asking. And the better the more context you give when you ask a question, the better answer you get. Ben really wants me to get off the stage now.